Okay, so you want to enlarge a design that's printed on a card that's 5 by 6. I'm going to sketch that card over here just so you can see it. This is 5 inches by 6 inches, yeah? Now, you'll draw this design on paper that is 8.5 inches by 11 inches. You're enlarging it by drawing it. What are the dimensions of the largest complete enlargement you can make? Okay, so if we then say, okay, we're trying to scale it up to this piece of paper that is 8.5 inches by 11 inches, then the question becomes, what number would we multiply this by? 6 times what would equal the 11 inches? Okay, and same thing here, 5 inches times what would be the 8.5 inches. Actually, so I'm going to erase this and rewrite it better for you. But really what we're saying is this. We're saying 6 times some value x, excuse me, will equal 11. And you can see that solving for x, we would say divided both sides by 6, we would get x equals 11/6. Yeah? And likewise, you would say, let me change the color just to make the kind of visually a little bit easier. You would say 5 times, let's say, y needs to equal 8.5. Divide both sides by y, divide both sides by 5, and we get 8.5 over 5. Or if I was to scale that up by multiplying top and bottom by 2, so you had whole numbers, y equals 17 over 10. Okay? So the question is, which is the smaller number? Because here's the idea. We can, if we need to multiply, let's say, 5 by 17/10 to fill 8.5, but that makes the other direction, the 6-inch height, become too long, then we can't multiply by that. So we got to pick the smaller of the two numbers. So how do we compare two fractions? Well, let's do it down here in the corner. I'm going to pick a different color here. I'm going to say we're going to compare 11/6 and 17/10. And when you compare two numbers, what you do is you multiply this way. You take the numerator and you multiply by the denominator, the denominator of one times the numerator of the other and write that number up above it. That is 110. And then you do the same thing again in the other direction. You do the denominator times the numerator and then write the answer up. And when we do that, we get 6 times 17, 102. And whatever has the larger number over it is the larger amount, the larger fraction. So we know that because 110 is larger than 102, then 110 is the larger fraction. We need to pick the smaller fraction. So we need to pick 17/10. That's what we want to multiply them both by. Okay? I can talk about that later, but if you're comparing two fractions that are unequal, you want to find out which one's bigger. You do denominator of one times numerator of the other, write that number straight up, and then do the same thing in the other direction, and whatever has the bigger number over it is the bigger fraction. So we know that we really need to be multiplying both things by 17 over 10 on the small triangle, or the small rectangle, in order to get the measurements that we want. So watch. Okay, so we will then say 6 times 17/10 equals what? I'm going to actually cancel out a 2 here from each of these, and we get 3/5. And now when we multiply across, we get 3 times 17 is 51/5. I'll talk about that in a second. But actually, if you simplify this by saying how many times does 5 go into 51, it goes in 10 times. How many are left? 1/5. So we could scale this side, that 6 side, scale it up to be this side, but not quite that full height. We can only go up to 10 1/5 inches. Let's do the same thing with the other measurement, 5. We say 5 times 17/10. And we need to, let's cancel out what we can cancel, divide them both by 5s. That becomes a 1. That becomes a 2. And we get 17/2. How many times does 2 go into 17? It goes in 8 times. Using 16, there's 1 left over. And as you can see, the 8.5, that's what this bottom side measures. That means we're completely filling the bottom side, scaling 5 up in order till it fills the bottom side. But this purple side is actually going to level out here at 10 1/5 inches. So then we have measurements of 8.5 by 10 1/5 inches. And where do we have that answer? That is B. Okay, so to recap, you want to take the measurements of the original design, and I'm going to use my laser tool here to point. The original design has a 5 by 6 dimension, 2 dimensions, 5 by 6, and you say, okay, well, if the small dimension, 5, was scaled up to fill the small dimension of the paper you're trying to fill, 8.5, what will we multiply it by? And you find that number, and then you say the same thing here. If we wanted to scale 6 up to perfectly fill the height of the paper that you're going to be drawing it on, 11, what will we scale 6? What will we multiply 6 by to make it fill 11? You'll find 2 different numbers. Here I'll mark out which 2 numbers I'm talking about. For the length of 6 to go up to 11, we found out that it was this. And for the bottom side, 5 scaling up to 8.5, we found out that it was that. And then we got to pick the smaller number because we're always limited by the smaller one that will fill the thing up. Okay? Let's try it with another problem on the next. Okay, you're reducing a map of dimensions 2 feet by 3 feet to fit a piece of paper 8 inches by 10 inches. So essentially what we can say is that 2 feet by 3 feet, if we turn it into the same units, okay, 2 feet, let me sketch this out. 2 feet by 3 feet. If we actually turn that into inches to see what that measurement would be in inches, we would get 3 feet would be 36 inches, and 2 feet would be 24 inches. Okay, so we're going to take our 8 by 10 paper. Let's just do the thing we did before. 8 inches by 10 inches. Okay, now we say, excuse me, what do we need to multiply 36 by times what to get the longer length of 10? Okay, and we can then divide both sides by 36. 36x divided by 36 equals 10/36. X equals 5/18. Okay? And then let's do the same thing for the other direction, the 24. What do we have to scale 24 down? 24 times what? Let's call this one y. We give you 8 inches. And if you do 24y divided by 24 equals 8 divided by 24. You get y equals 1/3. Okay? Okay, because we have these numbers, what we want to pick is the smaller number. We want to, in this sense, because we're going big and multiplying by some fractional amount, we want to have the smaller fraction because we need to make sure that we scale them all down uh, small enough. So, which is the smaller fraction? I'm going to show you what we did on the last one. We'll do this thing again. We'll take the fractions 5/18 and 1/3. 5/18 and 1/3, and we're going to compare them by multiplying. Okay, so we say 1 times 18 is 18, and 3 times 5 is 15. The smaller number is over 5/18. That means that's the smaller fraction, and that's what we're going to have to multiply by. Because if we pick the bigger fraction, watch what's going to happen. I'm going to zoom back out, and let's say we took 1/3 of everything. Okay, and let's take those inches. Let's say we took 1/3 of 36. 36 times 1/3 or divided by 3 gives us 12. Okay, 24 times 1/3 gives us 8. So that would give us a side that fit the 8 side on this small one, but then the other side would be 12, and we don't have 12. We only have 10 inches of length that we have to fit in there. So using the bigger one, 1/3, is actually going to leave us with a bigger amount on the 36 from 36, 12 than what we have as a length. So we have to pick the smaller one, 5/18. We need to multiply them both by the smaller number. So we're going to do that. We're going to do 36 by 5/18 and 24 by 5/18. Okay? So doing it again. 36 inches, the length in terms of inches, times 5/18. And fun fact, we can cancel 36 and 18 both by 18. So this becomes a 1, this becomes a 2. And you see that that results in a 10. That's great. That's the length that we want. We have this length of 10 over here on the right-hand side. And that works. Now let's take 24, the width, and do the same thing for it. We're going to take 24 times 5/18. And although 24 and 18 don't cancel by 18, they do cancel by 6. So this is 4. And this is 3. And we get 20 thirds. Or if we were to simplify that, 3 goes into 26 times. That's 18. So there's 2 left. And that would be the dimensions on that way. So we can do a 10, filling up the length, by 6 2/3, not quite filling up the width, but that's okay. So this is choice A, 6 2/3 by 10.